Okay, today's lesson is Chapter 8, Lesson 7. We should be on page 654. And we're going to be focusing on solving inequalities. So this is very similar to solving equations, especially for addition and subtraction. So the first thing we're going to talk about is using addition and subtraction properties to solve inequalities. So when you add or subtract the same number from each side of an inequality, the inequality remains true. So if you add 4 to both sides, 5 is less than 9. But if you add 4 to both sides, you create 9 is less than 13. That's still a true inequality. And on the other side, if you have 11 is greater than 6, but subtract 3 from both sides, you still have a true inequality of 8 is greater than 3. These properties are also true for the symbols less than or equal to and greater than or equal to. Very similar to the what we did with the addition properties of equality when we did equations. Okay, so let's look at a couple examples they've done for us. If we're going to solve x plus 7 is greater than or equal to 10, then we're going to actually represent it on a number line. Okay, this is the one difference in solving for equations, because equations would only have one solution and inequalities have an infinite number of solutions. So if you have x plus 7 is greater than or equal to 10, you subtract 7 from both sides to create that zero pair. So this leaves the x by itself. Now the symbol is different. It's greater than or equal to instead of just an equal sign. But x is greater than or equal to, and then once we subtract 7 from this side, the answer is 3. So we have to decide whether the boundary point is going to be an open or closed line. Now because x could be equal to 3, I said line again, it should be a closed dot. Okay, so we have a closed dot for 3, and then everything that's greater than 3 has to be shaded in as a possible solution. Okay, so then for number 2, we have x minus 3 is less than negative 9. So if you x minus 3 is less than, so then we're going to add 3 to both sides. That isolates, again, the x because that is a zero pair that we've created. X is less than negative 6 because negative 9 plus 3, you would actually jump back 3 to the positive direction, land on negative 6. And remember the rule about absolute value. So negative 9 has a larger absolute value, so that means that negative will be the answer. 9 minus 3 is 6. That's where we got that from. And so whether the next question is going to be, is the point going to be an open circle or a closed circle? Now, because negative 6 cannot be the answer, it has to be less than negative 6, we're going to have an open circle, and then we're going to shade in everything that is less than negative 6 to the left. Okay, so now we're going to try a couple of these on our own. So the first thing I'm going to do is I'm going to recopy down where I have some more space. I'm going to recopy the equation. N plus 2 is less than or equal to negative 5. Okay, so now I have to ask myself, I want to get n by itself. What do I have to do to this plus 2 to get rid of that? Go ahead and answer that for me, please. Of course, we're going to have to subtract 2. That creates a zero pair. Now the n's going to be by itself. So we have to copy down the symbol. N is less than or equal to. And if we do minus 2 on this side, we also have to do minus 2 on this side. So this is where we have to kind of be careful. If we have a negative 5 and we subtract 2, and I can kind of see on this number line here, if I'm at negative 5 and I subtract 2, that means I'm going to, actually, you know what? We're supposed to write this as an additive inverse. So if we have negative 5 minus 2, that's the same as plus what? This is actually a positive 2 here, minus a positive 2. What's the opposite of positive 2? Negative 2. So what is negative 5 plus negative 2? The answer is negative 7. Now you could also have gotten that same thing by thinking minus a positive 2, minus, you could get that as well that way. Okay, that was clear. All right, so n is less than or equal to negative 7 is what we have to plot as our solution on this number line. So is the negative 7 going to be an open dot or a closed dot? Go ahead and answer that for me. Negative 7 is going to be a closed dot because it says that it could be equal to. Okay, so it could be equal to negative 7, or it's going to be, any of the solution is going to be less than negative 7. So am I going to shade in the right side or the left side? Answer that for me now. All right, the left side is going to be shaded in because less than is the left part. Values get lesser as you go to the left. It's better to owe someone only negative $7 than to owe someone negative $10. So all of these are going to be possible answers, including negative 7. All right, so we're going to go ahead and look at the next one. I'm going to clear the board. Okay, rather than erase, I just decided to change colors. So the first thing we're going to do is we're going to copy down the inequality somewhere where we have room to work. So we're going to write down y minus 3 is greater than 9. Okay, so I want to get the y by itself. So what am I going to do to the minus 3 in order to get rid of that? Go ahead and answer that for me now. So to get to y by itself, I'm going to add 3. So we have minus 3, now we're going to add 3. So if I add 3 to this side, that creates a 0 pair. Then I have to add 3 to this side. 9 plus 3 is what number? I got the first part of it for you. Answer it for me. The answer is 12. Okay, so then we're just going to bring down the symbol. So y has got to be greater than 12. That's the possible solution. So the next question I ask you is, should there be an open dot or a closed dot for the first possible solution, which is 12? All right, the answer is going to be open dot. 12 is not a possible answer. It's got to be something that's greater than 12. So now the next question is, are we shading in the left side of the 12 or are we shading in the right side of 12? Answer that now. All right, my line's slightly askew, but everything to the right of the number 12 is going to be a possible answer, but not the number 12 because y is greater than 12. All right, let's go ahead and talk about multiplication and division. Okay, we're going to use multiplication and division properties to solve inequalities. When you multiply or divide each side of an inequality by the same number, positive number, the inequality remains true. So this is going to be exactly the same as how we solved equations, except do you notice how it says positive number? Okay, I'm going to go ahead and underline that. This is really important. As long as it's positive, it's going to be the same. But when we are going to multiply or divide by a negative number, something very different happens. So I want you to pay attention here. When you multiply or divide each side of an inequality by a negative number, trying to draw a straight line, not working too well, the inequality symbol must be reversed. It must go backwards for the inequality to remain true. Okay, so here's an example of a positive. So if we have 5 and is less than 10, 5 times 2, that is positive 10. 10 times 2, positive 20. And 10 is still less than 20. Okay. But if you have 16 is greater than 12, and we divide by, a negative 2, that's a negative 2 groups, then that's going to end up turning this number into a negative 8. And so when we divide by the negative 2, do you notice the symbol changed from a greater than to a less than symbol? It has to flip around. So 12 divided by negative 2 is negative 6. So now that we flip the symbol around, it is still true. Negative 8 is less than negative 6. If we had not turned the symbol around and negative 8 was greater than negative 6, that would not be true. So anytime you do a negative operation on both sides of the equation, you have to flip the comparison symbol. That is a huge difference, so make sure we remember to do that. All right, so we have negative 5 times x is less than or equal to 45. Represent the solution on the number line. So this is what we just talked about. In negative numbers, we have to be very careful with those. If you have negative 5x, you want to get rid of the negative 5. In order to get rid of the negative 5, we have to divide and do the inverse operation. If we divide both sides by negative 5, you have to switch the less than or equal to sign to greater than and equal to sign. So we're going to get the x by itself, but now it's greater than or equal to. And then 45 divided by negative 5, a positive divided by a negative is a negative. That's going to be negative 9. And so x is going to be anything greater than or equal to negative 9. So over here, negative 9 is a possibility. So there's got to be a closed boundary point. And then we're going to shade in everything that is greater than negative 9 as a possible solution. The next example they did for us is that x is divided by 8. That's greater than 3. So you'll notice that all of these are positive numbers. We don't have anything to worry about. So we have divided by 8. So the inverse is to multiply by 8. And remember, this creates 8 over 8, which is 1. And so we just have 1x. So that cancels those two things out. So then 3 times 8 is 24. So the solution is that x is greater than 24. And you'll notice that 24 is an open circle because 24 is not a possible solution, but everything greater than 24 is, so we're going to shade everything in on the right. Okay, so we're going to do these two examples, and the first one says that 10 times x is less than 80. So we're going to get rid of that 10 first. Since it's multiplication, I'm going to rewrite this problem over here so we have more room. So we have 10x is less than 80. Okay, so in order to get rid of this, it's a multiplication problem, what operation are we going to need to do? Very good, we're going to need to divide, and we're going to need to divide both sides by the same number. But because we're dividing by a positive number, nothing changes. The x is going to stay the same. This becomes the number 1, so that cancels out. X is less than. The operation stays the the comparison symbol stays the same because we had divided by positives. So the final answer you need to come up with here is, what is 80 divided by 10? Go ahead and answer that for me, please. Okay, that is actually 8, and you can actually see, you can actually cancel out the zeros here. 8 over 1 is 8. Is this going to be an open boundary point or a closed boundary point? Answer that for me, please. 8 is not a possible solution because it has to be less than 8. So it's going to be an open boundary point. Do we shade the left side of the number line or do we shade the right side of the number line for the possible solutions? Answer that for me now, please. Okay, x is going to be less than 8, so everything on the left has to be shaded in as a possible solution. All right, I'm going to change my color and we're going to do the next problem here. X divided by negative 6 is greater than or equal to negative 7. So I'm going to write this down. We have x. So it's a little too chunky. I'm going to change the line. Size x divided by negative 6 is greater than or equal to negative 7. Okay, what do we need to do to get rid of, isolate the x if we are dividing? What operation should we use? What's the inverse of division? Answer that for me now, please. Okay, you've said multiplication, that's correct. We're going to multiply by negative 6, and that's going to create negative 6 over negative 6. That's going to become the number 1, and so this will isolate the x. But if we multiply both sides by a negative number, we have to flip the comparison symbol. So x, instead of being greater than or equal to something, x is now less than or equal to something. So go ahead and answer this question for me. If we multiply two negative numbers together, is that going to be positive or negative? And so please tell me what negative 7 times negative 6 is. That will be positive, and the answer is going to be positive 42. Okay, so when we write that on the number line, are we going to have an open symbol for 42 or are we going to have a closed symbol? Answer that for me, please. It's going to be a closed symbol because 42 is a possible solution. It says x could be equal to 42. But are we going to shade the left side of the equation or the right side of the equation? Answer that for me now, please. Okay, the answer is the left side of the equation because it says that x could be less than 42 or equal to 42. So everything that's less than 42 is going to be a possible solution. That goes on forever infinitely. Okay, So now we're at that point where we have to stop and think about, okay, what were the important things that we learned in this lesson? And if you are, if your brain's frozen, you're like, I don't know, I don't remember, I forgot. Well, please look over the last 2 pages of your notes and think of one thing that would be important for us to remember. Especially, I'm going to give you a big hint here, thinking about multiplying and dividing by negative numbers, that's something that might be important. What happens when that occurs? Anyway, so that's your hint. Answer the question for me, please. Okay, thank you for your thoughtful answer. And there were several things that were important, so there any number of things could be correct there. But the only thing that won't be correct is I forgot or I don't know, because we're not going to just give up. We're going to do our very best. Please make sure that you look through your lesson, that you've completed all independent practice, you've completed practicing your vocabulary flashcards, and you've done some Imagine Math Minutes today. Thank you, and I will see you tomorrow.